Alright, hello to your second video that's going to go straight into your acid-base notebook. This time we are going to have a reaction between a strong acid or a strong base. It'll be the same type of problem. Here we're dealing with hydrochloric acid, which we know is a strong acid. So this is not a strong base problem, but again, the steps are exactly the same. So calculate the concentration of HCl, H+, OH-, and then also calculate pH and pOH. Then identify if the solution is acidic, basic, or neutral when 50 milliliters of 0.20 molarity HCl is diluted to 200 milliliters with distilled water. Alright, so first step is, as I promised you last time, the same. Identify the major species. So, what is the most important species that we're dealing with here? It is our hydrochloric acid, which we know is a strong acid. If it is a strong acid, can we write an equilibrium expression for it? Your answer should be no, we cannot. So let's write out the reaction and see what we'll end up doing instead. Write out the reaction. HCl, and it completely dissociates, so use a one-way arrow. H plus Cl minus. Okay, so let's write down that step about writing out the equilibrium expression, and then we're going to deny it. So write out equilibrium expression. And then you're going to say no equilibrium expression, there's none. Strong acids and bases don't go to equilibrium. They completely dissociate. So instead, what we're going to do is a dilution. Last time we didn't do a dilution, this time we will do the dilution. These problems are basically always going to have the same first three steps, and then you're going to either do a dilution or an ice chart. So a dilution, we know dilution problems basically always involve an M1 V1 equals M2 V2. So here our initial concentration is 0.20 molarity, and our initial volume is 50 milliliters. So we'll write that first. So we'll have 0.20 molarity times 50 milliliters. And then we're trying to find the new concentration. It's been diluted, so M2. And our second volume, it said it was diluted to 200 milliliters of water, not diluted with 200 milliliters of water. If it was diluted to 200 milliliters of water, that means that the total volume at the end is 200 milliliters. So now think to yourself, what if they had said it was diluted with 200 milliliters of water? What would that final volume be? If they had said diluted with, that final volume would be 200 plus the initial, so it would be 250. So just be careful with that wording. So you can go ahead and solve for M2, and you should end up with 0.050 molarity hydrochloric acid. However, we know that hydrochloric acid 100% ionizes because it's strong. HCl 100% ionizes. So at equilibrium, well, there is no equilibrium. At the end of the reaction, there is no hydrochloric acid, so this is not a correct statement. Instead, what you're going to want to say is, and I'll use my answer color, I guess we'll use green. At the end, we know we're going to end up with 0.050 molarity hydrogen ions and 0.050 molarity hydroxide ions. And if you're wondering, not hydroxide, I'm sorry, we are dealing with hydrogen and chloride, so it's 0.050 molarity chloride ions. Whew. Now, if you're wondering how I know that these two are equal to each other, you could just do mole ratios. You could say for every one hydrochloric acid, there is one hydrogen within it, and for every one hydrochloric acid, there is one chloride ion within it. So it's all 1 to 1. All right, so next we are going to, let's see, next we're going to determine the concentration of hydroxides within this reaction. It's reacting with water. They told us that. So determine the concentration of our hydroxides. We always are interested in the concentration of hydrogens and hydroxides. So as we have recently learned, the concentration of hydrogen ions times the concentration of hydroxide ions is always equal to 1.0 times 10 to the negative 14. This is a tool you can use in basically every problem you ever do. So we know the concentration of hydrogen ions from over here. I'm going to plug that in to my problem. 0.050 molarity times my concentration of hydroxide is equal to 1.0 times 10 to the negative 14. So now you can solve the hydroxide concentration is equal to, and, oops, sorry, hopefully that wasn't too loud. The hydroxide concentration is equal to 2.0 times 10 to the negative 13 molarity. Be careful not to forget those units. So let's see what it's asking for. We got our concentration of hydroxide. We've got our concentrations of these individual ions. I mean, we know that we had 0.050 molarity hydrochloric acid, however, it 100% ionizes. So our final step is to figure out the pHs. So calculate or solve for pH and pOH. All right, well, we know that All right, we know that pH is the same thing as the negative log of the concentration of hydrogen ions. So we can plug in our number, negative log of the hydrogen ion concentration we got earlier, 0.050 molarity. And you should end up with a pH that is equal to 1.30, so that's part of our answer. And we also know that the pH plus the pOH is always equal to 14, which tells us then that our pOH must be equal to 12.70. Great. And now let's compare these numbers here. pH of 1.30, that's a very low pH. And we know that the smaller the pH is, the more acidic something is. So this thing is highly acidic. More acidic than lemon juice. It is acidic. All right. Great. So that is that problem. Now, if you wanted to know how to solve this equation for a concentration, just take a look at the bottom of this page here. I'll use a different color. I'll use red. So let's say we want to know what is the concentration of hydroxide. And let's say that I know what the pOH is. Let's pretend, well, let's use the pOH from this problem. It's equal to 12.70. So what you could say is that 12.70 is equal to the negative log of the concentration of hydroxide. That's what we're interested in. And we learned a couple of units ago now that if you take whatever the base is of your log, you can use it to cancel out that log. So if a log doesn't have a base written in there, we can assume it is log base 10. This is the same thing as negative log base 10 of the concentration of hydroxide ions. I'm just going to rewrite it over here. 12.70. Okay, so what I'm going to do then is I'm going to take the number 10. I'm going to say 10 to the negative log base 10 and 10 to the 12.70. And what this ends up giving you is that the concentration of your hydroxide ions is equal to 10 to the negative 12.70. It has to do with this negative symbol up here. You need to bring that over. You need to bring it over. So what we would have done is taken this negative symbol before we did this. Here, I'll make this side, I'm going to multiply everything by -1. That'll become positive. This will become negative. Let me use green for that so you can see. That is positive, that is negative. So we have the concentration of hydroxide is equal to 10 to the negative 12.70. And if you do the math on that, you should end up with the same concentration that we had up here at the beginning, which is pretty cool. So this is an aside, this is unrelated, it's just extra practice. Oops, let me write that down so you don't get confused. This is unrelated example down here. Alright, so there you go. This will be the next thing that you want to include in your acid-base notebook.